A tornado outbreak is one of nature's most destructive forces. In 2011, a single violent outbreak of tornadoes in the U.S. killed hundreds of people and caused billions of dollars in damages. The ability to predict tornado outbreaks a season or more in advance could help society to better prepare, potentially preventing significant losses of life and property. So how can scientists better predict when and where tornadoes are likely to strike before the tornado season begins? A recent study suggests that the climate patterns known as El Nino and La Nina might hold a clue. The tropical trade winds, which blow from east to west, normally drive equatorial ocean currents that pull up cold water from the deep, making the surface cold in the East Pacific. These winds also push the warm, sun-drenched surface waters of the tropical Pacific toward the west, piling it up in a thick, warm layer near Indonesia. The warm waters of the West Pacific feed moisture into tropical thunderstorms, which help drive global weather patterns. But every few years, the trade winds weaken, and the warm surface water near Indonesia sloshes eastward, bringing with it tropical thunderstorms and torrential rains. This is the phenomenon known as El Niño. The opposite situation, La Nina, occurs when the trade winds are stronger than normal, boosting the upwelling of cold water in the equatorial Pacific and pushing the warm water in thunderstorms even farther west. These Pacific temperature variations have far-reaching impacts on global weather, including the likelihood of tornado outbreaks over the U.S. Using climate data collected over the past 60 years, a research team discovered that both the timing of U.S. tornado outbreaks and the regions where they are likely to occur could be related to El Niño and La Nina. The scientists focused on 4 different types of El Niño and La Nina events: strong winter events that persist well into spring, and weak events that dissipate soon after their winter peak. The patterns that developed were distinct and consistent with the atmospheric conditions conducive to tornado outbreaks, such as increased wind shear and the convergence of warm and moist air originating from the Gulf of Mexico. They found that weak El Niños led to tornado outbreaks in May throughout the upper Midwest, while strong El Niños led to outbreaks in February across central Florida and the Gulf Coast. In contrast, weak La Niñas led to April outbreaks throughout the South, particularly Oklahoma and Kansas, while strong La Niñas led to April outbreaks along the Ohio Valley and in the Southeast and upper Midwest. The strongest connection to tornado activity was through strong, persistent La Niñas, consistent with the super outbreak of 1974 and the record-shattering outbreaks of 2011, both of which occurred during strong La Niñas. Despite these connections, there is still a large element of chance. An outbreak can occur in any season and almost anywhere in the U.S., regardless of the state of El Niño or La Nina. The researchers' current work is aimed at incorporating the El Niño state and other potentially important climate patterns into statistical and dynamical models that can reliably forecast the likelihood of U.S. tornado outbreaks 1 to 3 months in advance.